This talk is about a paper that we published last year, and I just took exactly the same title for this talk. So apologies for people that are aware of the paper. I thought it was a good paper to present to you to show how we can triangulate evidence and what kind of question you can address with sometimes you know, data that the site doesn't seem to relate to one another. So that work was carried out during the NeoMILS project, which ended in oh no. I'll go back.
I can take this.
I'll go back. That's fine.
I think you don't have to stand right next to it.
Yeah, that's fine. Too far. Thank you. So that work was carried out during the NeoMILS project, which ended in 2019. So it's been like 4 years in the making, and it's a big collaboration between the University of Bristol. So Evershed was the lead PI for in the NeoMILS ERC project. And it's a big collaboration with University College London and Mark Thomas and his team, and George Davey-Smith, who is an epidemiologist at the University of Bristol, and a lot more collaborators that I will show a slide for at the end of this talk. So when people started consuming milk after domestication of the animals, they set in motion a whole series of events that triggered a widespread presence of the lactase persistence allele in European population. So as you can see from this map, you have a lot of people that are lactase persistent in the north, almost 100%, and then less in the south, which means that they can digest the lactose in milk using the enzyme, the lactase enzyme. So our question was, how do we explain that trend in the modern population? And before our work, the main idea was that milk use had triggered that pattern, and the selection for this lactase persistence allele was due to important milk use and the benefits you can get in drinking milk and digesting the lactose if you're lactase persistent, and avoiding all the ill effect of consuming milk if you're not persistent to lactase. In order to tackle that question, we used 3 lines of evidence, as I mentioned before: pottery, ancient DNA, and epidemiology. So pottery was kind of my part. So this was the way we used in order to assess milk use through time and space in Europe. And what we used is the lipids preserved in pottery vessels that are absorbed during cooking events. So what we can do is extract those lipids and then characterize them using analytical methods, chromatography and mass spectrometry. We use the molecular methods to identify animal fats, and then isotopic methods to identify fat types. And it's just a kind of bit of a subset of modern reference data that we use, and from it you can see that we can distinguish milk from meat, from ruminant and non-ruminant. So we plot usually those types of graphs with like the big delta there, where at the bottom you have milk fats and at the top you have meat. So we have a method to look at milk use in pottery. And I need to highlight that it's not species specific, so we can't tell which type of animal the milk is coming from, but we can say it's milk and it's based on metabolism and biosynthetic pathways, so we understand why typically we can distinguish milk from meat. So what we did was collating a whole bunch of published data from poultry analysis over time that was carried out in the last almost 30 years. And to that, we've added as well a big data set that we collated during the NeoMill project. And all in all, we got more than 13,000 pochards and more than 500 sites that dated back to 7,000 BC up to 1,000 AD. And here is kind of the summary data. So every data point is assured that we had georeference and had a secure date associated to it. And in blue, you can see all the milk fat, and in red, all the meat fat. And at the bottom is time. So as you can see, throughout prehistory, people were using milk. If we do kind of a percentage, a percentage of dairy fat in pots, depending on time, you can see that there's fluctuations. So at times, people were using more milk than at others. We made as well time series and maps, and from those ones where in red you have sites where everything is milk, but like all the residues in pots are milk, and then in yellow it's no milk. So you can see how varied it is through time, but also through space in Europe. So we rationalize that there's kind of regional specific instabilities in food production and some cultural changes in the diet of prehistoric people. So next, when we have this good idea about milk use in the past, we collated ancient DNA evidence for lactase persistence, so looking at human remains and whether they had the LP allele, the LP European allele. And what we saw was that the first evidence for lactase persistence in human bones and the time where the LP allele increase in frequency are very two different events and are separated by thousands of years. So using those two data sets, then Mark at University College London and Adrian Timpson devised like a maximum likelihood modeling approach in order to test whether the LP selection evolution was better explained by constant selection or by milk use. But we had the proxy for using pots. And to our big surprise, it wasn't. So there was no difference in probability of genetic data given constant selection or milk use driving selection. So it means that there's something else but just the use of milk that is driving the selection for lactase persistence. So because it was a bit surprising, we kind of went to the modern and talked to an epidemiologist about that to see whether there was evidence as well in the modern of the non-effect of milk use in lactase non-persistence individual. So we got access to the UK Biobank, which is like a huge database with data from hundreds of thousands of people. And analyzing the data, we saw that more than 90% of people that were lactase non-persistent were consuming fresh cow's milk. And they reported well, and statistically we showed that there was very little or no adverse health effect on lactase non-persistent individuals that were consuming milk in a healthy contemporary population. So that idea that the selection again against lactase non-persistence was simply resulting from the detrimental effect of milk use and milk consumption in a healthy population of lactase non-persistent individual was not correct. So then kind of thought about other explanations and came up with different factors that could have affected fecundity and mortality in prehistory. So one is, you know, with the introduction of farming at the time, when people started to have access to milk, you've got an increase in settlement density, you have an increase in mobility as well. You've got a lot of proximity with animals and domesticated animals particularly, but it's kind of go with poor hygiene and sanitation. So you have like probably like a lot of infectious disease and zoonosis. You know, even nowadays, more than 50% of the new disease are actually coming from animals. I don't know whether I need to remind you about that disease, starting back with co and ending by vid, that we had a few years ago, and which was clearly a zoonosis as well. And the other factor we thought about was crop failure and famine, and you know, kind of those population collapse thing. So coming back to our hypothesis, we tested whether famines could explain this LP evolution better than content selection. And for that, we used the fluctuations in population size. And this proxy was explaining the genetic data almost 700 times better than the milk use hypothesis. So it looks like this was a driver. Famines were a driver for the selection for lactose persistence. And the other idea was the increased pathogens loads. For that, we use temporal variations in settlement density using radiocarbon-dates. And again, this was explaining the data much better than milk use. So from that, we proposed two related mechanisms for the selection of lactose persistence. One being the crisis mechanism that have been proposed already by Rodney and Mark, which is about the fact that during famine, if you're under starvation conditions and you have milk but can't digest the lactose and can't get the nutrition out of it, because you're lactase non-persistent, then you will, you know, it's a matter of dying or surviving. And, you know, having diarrhea as well, if you can't digest the lactose at the time of famine, would be very detrimental then. Our other mechanism that we propose is a chronic mechanism where you have a more continuous selection through time in a population where people are already quite strained under pathogens and have like poor health, and so having again diarrhea from that is probably going to be fatal. So just like the take-home message from this paper was that the spatial. Oh, okay. So what I should have said is those mechanisms are not mutually exclusive, so they could have happened at the same time. Well, throughout prehistory, alongside one another. We couldn't really choose between the two mechanisms. And so the take-home message is that well, the LP selection is not doesn't reflect variation in the milk consumption and the changes in milk consumption through time and space, but instead, and it's actually like a sentence.
Good morning. Happy opening night. Hey.
So it's a sentence from the paper. So both patterns map latitude, population collapses, and settlement densities, subsistence economies, and pathogen exposure. So looking at those three lines of evidence, we've been able to kind of get access to the evolution of lactase. Let me thank all the people that were co-authors on that paper we published. So all the archaeologists we've been working with in the last 20, 30 years even, that have trusted us with their pottery to work on, and nothing would have been possible without them. So we're very grateful. And yeah, that's the end of me.